It is asynchronous communication, and like we are using a Baud generator
Okay.
uh, in place of clock.
Okay.
There is no clock signal here. Uh,
Yeah. Yeah.
and full form is universal asynchronous receiver and transmitter. We can connect only two devices in a UART, and there is in UART we will send data as a 8-bit frame, and here uh, like we will send stop and start signal and stop signal, and here that in UART
Yeah.
like there is a data limit.
Okay.
There is a data limit,
Okay. Yeah.
and we.
Thanks. Those questions
Oh,
will
yes.
be asked in the next slides. So,
Okay.
okay. Yeah, that's enough. Yeah, good. So, UART is like you're correct. Universal asynchronous receiver and transmitter is a hardware communication protocol used for serial communication between the devices. It's a short answer, but yeah, you can give a elaborated answer also. Yeah, that's good.
Okay, sir.
Next, difference between synchronous and asynchronous communication.
Synchronous communication means when any two domains are working with respect to the clock, with respect to the same clock. That means these two domains are synchronized with the same clock, so that they can the transmitter and receiver can no data corruption will be there.
Okay.
The data what the transmitter sends can be received by the receiver.
Okay.
In asynchronous communication, the two clock domains are different frequencies.
Okay.
The clock domain 1 is with some frequency, and clock domain 2 is working with some frequency.
Okay.
Here, if transmitter wants to send some information, there will be a data corruption. If there is no synchronization between the two domains.
Yes.
Yeah.
Yeah, you're correct. So synchronous communication requires a shared clock signals between the devices, while asynchronous communication like UART does not use a clock signal, relying instead on start and stop bits for the synchronization. Okay. Yeah, you're correct. Next, what are the key components of a UART? I hope I think you have already answered in the first question itself all the key components. Okay. Anyways, give a short answer.
Like sir, baud rate we are using, and data bits can be 6, 7, and 5.
Yes.
Sorry, 8.
Yes.
And parity bit we are using, and before we are sending the data, we will send one start bit, and when that 8 data bits we will send for showing that like transfer complete, we will send one stop bit. And, yeah,
So these are the
it
key
will be used in
components like transmitter.
half duplex mode.
So these are the key
Mostly.
components: transmitter, receiver, baud rate generator, and control register. Right?
Yes sir. Yes sir.
Yeah. Sir, I think in UART module, there will be some component which converts. Here, UART is getting the parallel data from the system. So here, the parallel data can be converted into serial data. Here, in UART, there can be parallel to serial converter.
Like the question is, what it's like. It is asking like, what is the significance of the frames? How does the UART handle the
It can.
data frames?
While getting the parallel data itself, it can. If parallel data is received by the UART transmitter, then the UART transmitter will add the some bits. It will make a frame.
Okay. Yeah.
Such that the UART receiver can acknowledge the whether it is receiving or not. The some is a start bit is there. If start bit is control signal. If start bit is 0, some operation will be performed. If start bit is 1, some operation will be confirmed.
Yeah.
Like that, if start bit is I don't know exactly. If start bit is 0 or 1, any for one value, it will get receiver who knows whether the data is coming or not.
Yeah.
Then after in transmitter and receiver, it will get in transmitter itself. We calculate the parity bit. Based on the parity bit, we can know whether data is whether data is same or not at the transmitter level and receiver level.
Yes.
Then after that, we have stop bit. In the stop bit, then data is completely transferred to the receiver. If the receiver knows that it can stop the transaction.
Yes. Correct.
This
Yeah, you are correct. So UART frames data start with a start bit, 5 to 9 data bits, and optional parity bit, and one or more stop bits. Okay. Start bit is used to indicate that frame starting, and data bits is our raw data, and parity bit to know the error, and stop bit is to tell the receiver that this is the end of the frame. Okay. Yeah. Next question is, what is the role of start and stop bits in UART communication? Actually, the answer is also visible. So I'm changing the slide. I'm just showing the question. So what is the role of UART start bit and stop bit? I hope we have discussed this also now only. So the role of start and stop bits to indicate the start of the transmission, and the stop bit is to indicate the end of the transition. Right. Next. Significance of parity bit also we have discussed now only. So parity bits are used for simple error detection by ensuring the number of ones of the data is even parity, or odd parity. Next question is, what is the maximum UART baud rate we can achieve? Yeah, what is that value?
so
So I think
I think
19200.
1 lakh
Okay.
100 will be
So the maximum baud rate depends on the hardware, but it typically ranges from 1 Mbps to 3 Mbps. Okay. So according to the hardware application, it depends. Next, explain how UART can be used to communicate with other peripherals. You can give an example also. Like you can explain how UART is communicating with other peripherals. Like you can give a short example of real time.
So like if you want to send data from CPU to some slave, we can use the UART protocol. And
Okay, what can be that slave?
that that can be like that microcontroller.
Okay.
Microcontroller.
Yes. You can use any microcontroller or FPGA or anything, and you can communicate with that with the help of UART. So UART can be used to communicate with peripherals like sensors, GPS modules, and Bluetooth devices by sending and receiving the serial data through TX and RX lines. Right. Next. So how do you calculate the baud rate divisor? Any idea? Using the clock frequency.
yeah, we have a system clock we have. From the system clock, we can derive the same baud rate.
Okay.
So for that, we have to we in these two possibilities are there. We can directly give that external signal to both the clock domains, or we can derive some certain formula will be there. That formula can be used, and from that formula we can derive the separate clock signals for both the transmitter and receiver working with the same baud rate.
Yeah. So the baud rate divisor is calculated as clock frequency divided by 16 into desired baud frequency. So this divisor value is loaded into the UART baud rate register. So this baud rate will be same for the both the transmitter and receiver. So both the transmitter and receiver should work on the same baud rate. So if there is any mismatch in the baud rate of transmitter and receiver, then there will be corruption in the data. Okay.
So why can't we give the system clock signal to both the transmitter and receiver? Why only we can use this form?
We need a specific baud rate, right? Like how many bits or how many signals we need to send, that should be calculated, right? So system clock may be very high. It may be in very high frequency. So we are basically decreasing the frequency.
So is there anything that transmitter will work this particular frequency and the receiver should work particular frequency?
If we do like that, it will be in a asynchronous, right? And there will be mismatch. There are chances of mismatching the data also in asynchronous communication. But We may
Yeah,
use asynchronous communication also. If we want, we can work the both modules, transmitter and receiver, with different baud rates. So in that cases, we can use techniques, CDC techniques, or we can do. We can also use this FIFO.
yeah. If we use asynchronous before,
Yes.
what is the condition that transmitter and receiver frequency, sir?
It depends on the
Whether it is
design, what we are doing. Both frequencies will be different, but it
yeah.
depends.
So transmitter must be less than receiver, or receiver must be less than the transmitter
Generally,
based on
generally transmitter will frequency will be higher than the receiver frequency.
uh,
So receiver will
if
be.
transmitter.
Hmm.
So transmitter frequency is high, then frequency the data from the transmitter is passing fast now. Then receiver can't
Yes, that's
take
why we are
the
using FIFO,
yeah
asynchronous FIFO.
yeah yeah okay
If transmitter is sending the data slowly and receiver is receiving fastly, then no problem in that case.
yeah. So there must be so receiver frequency must be greater than the transmitter
Yeah,
generally.
yeah, yes. Or else we will
Okay
use async FIFO.
okay. Thank you.
Yeah.
But sir, if receiver is sending fastly and sorry, transmitter is sending fast and receiver is not receiving with that rate, like
Mm.
there is a mismatch in baud rate, then there is a data loss, na?
Yeah, that's why we are using async FIFO. FIFO to store the missing data.
Asynchronous FIFO, right?
Yes, async FIFO. We can, but there is also a limitation. Like we can store up to two or three datas. That's it. And like FIFO depth, we should be calculating all that stuff will be there. So if FIFO depth is not so high, so we cannot store that maximum data also, right? And the
So we are
design.
already using the baud rate generator now. Then
Yeah,
why can't I?
I'm discussing about the case where there is no baud rate. So both the modules are
Yeah okay
working with different baud rates.
okay.
Yeah.
I am sure,
So
sir.
this is the case is like in every protocol, na, where is like data mismatch.
No. Actually, every in other protocols there will be handshaking signals, but in UART you don't have any handshaking signals, right?
Like acknowledgement, not acknowledgement in
Yeah,
I2C, right?
like in case of AXA protocol, you have ready signal, valid signal, all these signals. Like they will be used to indicate when the data is coming. Then the receiver will know when the data is coming at, and it will take the data like that. There will be handshaking signals, but in UART you don't have any, right?
Sir, here also start bit and stop bit. Now, how it is different?
But only with the start and stop it, you cannot achieve full handshaking. The thing.
Okay.
Yeah. Next, what causes overrun in UART? Like we are discussing this only. So overrun occurs when the UART receiver cannot process the incoming data fast enough, leading to data being lost as new data arrives before the previous data is read. Okay, this is the overrun conditions when receiver is not fast enough and the transmitter is very fast. Okay, and how does UART handle clock synchronization between the transmitter and receiver? This is also we are discussing. So UART does not use any shade clock. Instead, it relies on the start and stop bits to synchronize the data framing between the transmitter and receiver. But and it also depends on the baud rate. Okay, so if the baud rate is also different, we cannot achieve the synchronization between the two modules. Start and stop bits are also helping us to achieve the synchronization. But in real time, if you are using the UART and if there is any difference in the baud rate, you cannot achieve that. Okay. Yeah. Next, what is the role of UART FIFO buffer? This also we have discussed now only. So the FIFO buffer temporarily stores the incoming and outgoing data to handle the bursts of data and reduce the chances of data loss due to the overrun conditions. Okay. So up to here, is it clear?
Yes, sir.
So what is the impact of noise on UART communication and how can it mitigate? this also we have seen. So noise can cause data corruption, framing errors, and communication failure. So mitigation strategies include shielding cables. This is like it can be a physical form they are talking about, but we are more intended towards the protocol related. So I'm skipping this. Okay. So difference between UART and USART, USART. Any idea? Anyone can answer. Difference between UART and USART.
Yes, ART is synchronous protocol. Here it is asynchronous protocol.
Okay. So UART is for asynchronous communication only, while USART, universal synchronous or asynchronous receiver transmitter. Wait a minute. As communication only, while USART supports both synchronous and asynchronous communication. Okay. Next, how does DMA improves the performance of UART? Like any idea about this DMA? Direct memory access. Okay. So, like, can you explain the basic principle of this DMA, like how DMA works?
Not, not sir.
Okay, okay. So basically, this DMA is direct memory access. So, for example, if you have if for example, if a peripheral wants to communicate with the memory, right? So if a peripheral wants to communicate with the memory, you are what you will do. The peripheral will basically communicate with the processor, and the process. So the peripheral will send the data to the processor, and the processor will send the data further to the memory. Okay. So there is involvement of the processor. Okay. So in that, what happens? There will be some time taken. Okay. So with the help of this DMA, what you can actually do is the peripheral can communicate directly with the memory. So without involvement of the processor, the peripheral can actually communicate with the memory. Okay, so this DMA allows data transfer between the UART and the memory without intervention of CPU. So when you are using UART, you will be communicating UART with the processor and from processor to memory. So in the case of DMA, what happens is your UART will directly communicate with the memory without intervention of this CPU at all. Okay, so this will reduce the latency and improve overall system performance. Okay, is it clear?
So like if we will not use DMA, then first UART has to send that data to CPU, then the data will go to that memory.
Yes, the processor will only manage all these operations. The processor will be communicated to our UART.
Okay, so here latency.
Okay, is this clear? Next. So basically, error detection can be implemented using the parity bits or checksums, while error correction may involve retransmitting the corrupted data or using more advanced algorithms like Hamming code. I didn't say Hamming code using anywhere, but we can use, I think. Okay. Yeah. Next, how can you test UART communication in a hardware setup? Like, imagine this scenario. You have given a UART module, and you have given a hardware, and you want to test that whether that UART is working or not. How can you test it? Anyone can answer.
Yes, yes.
With that UART module, you will basically communicate with some microcontroller. All that examples we have seen, right? So before that, how to check whether that UART module is working fine or not? How you will check? So in real time, what happens is you will be given that UART module, and if it is not working, how can you decide whether it is a fault of that microcontroller or fault of that UART module in your hand? So how you will check?
Through hardware communication protocol we used.
Okay.
Universal asynchronous receiver or transcriptor we used to communicate.
Yeah, correct. But like this is a scenario, you have in your hand, you have a module, okay? So you want to test that hardware, how whether it is working or not. We have seen in a UART module we have transmitter line, receiver line, all that, right? So with the help of that, how can you check it? Okay, I will answer, no worries. So coming to this, UART communication will be tested by connecting TX and RX lines to a known working device using loopback mode, sending the known data patterns and checking with a terminal program or logic analysis. Or you can do, what you can do is, in a UART
Means
module you will be
transmitter or receiver TX and RX lines.
yes, yes.
That
So you will be
okay. Interface provided, the UART directly communicate with each other.
Okay, okay,
So
sir, you are telling that we have to connect that transmitter and receiver line to a working device, and that
yeah.
8-bit data or 10-bit data we have to check bit by bit.
Yes.
Ha, right.
Or else what you can do is, you can use a loopback mode in the hardware itself. In that, connect the transmitter line to the receiver line of the same module, and you can transmit the data. So what data you are transmitting, you can receive that data. So if you are receiving it perfectly, then you can say that that particular module is working fine, right?
Sir, how we will check this logic analyzer? It is like that PRBS.
No, no, no. I'm not talking about that logic analyzer. I'm talking about like if you have a hardware. Forget about this. I'm
Okay.
saying a simple example. Like if you are having in hand a UART module or UART hardware device, what you can do is, you will connect it to some CPU or any end to any end, right? And you can, what you can do is, you can connect the transmitter line of that UART to receiver line, and by sending the data from transmitter line, you can check it in the receiver line.
Okay.
Is this clear? For example, I will show one UART module. Wait a minute, let me pause the recording. So this is a U-port MOXA cable. What you can do is, other end will be a USB. So this is basically USB to UART converter. So the other end, that is the USB, you can connect it to your CPU, and you can open a terminal like Teraterm, or in the HDK you can open a console and you can frame a message. Okay, you can type a message, like any words you can type. So internally, that message will be converted into UART frame format, and it will be given through these pins. Okay, there will be TX pin, RX pin, TX plus, TX minus, RX plus, RX minus. So what you can do is, you can connect the TX to RX, and basically you are loop backing. Okay, when you send the signal, you can again receive it and you will check it in the console. So like this, using the loop back mode, you can check it. Okay, so this is one of the example. Okay, is this clear? So is this clear, how to check, how to test that UART communication?
Yeah, sir. Sir, like when the we will connect with some working device, and that same data we will send through that transmission
Yes.
wire of UART, and same data we will receive from receiver line.
Yes.
So we will check the same data we are receiving or not. By this way, we can check
Yes.
how
Yes.
UART module is working or not.
Okay, for everyone.
So like we can connect only maximum two devices, so there is no intervention can happen from outside.
Okay.
Simple data frame. It is only simple data frame.
Okay. Yeah. So the
It
advantage of UART.
is
Yes. Yes.
point to point and multi point and daisy chain communications.
Point to point, it is correct,
Mul-
and
huh, multi
multi
point
point. Mm,
and daisy chain
It
to
is using
device.
two wipes.
mm,
And it is
It
also
is
cost
only two wipes.
effective.
okay. Yeah. So the advantage of UART over other communication protocols include, you said it right. It's simplicity, low cost, and ease of implementation. And UART is also reliable and widely supported, making it a popular choice for many applications. And additionally, UART is used for communications over long distances. Next, what is the maximum data rate that can be achieved? We have seen this. So it is 11520 bytes per second. Next, what is the disadvantage of UART?
Disadvantage is that we can use maximum two devices, and there is some data limit. We can't use for a high speed communication. UART.
So it does not support multi-master and slave also, and you have to
Yeah,
select the appropriate baud rate for transmitter and receiver. Next, how many wires? This we are discussing from starting also. So there are two wires. Okay, transmitter and receiver.
yes,
So in which parity the number of ones must be even?
even.
Yeah, even parity is very important. Next, UART receiver transmitter can be simplex, full duplex, half duplex, and all of the above.
Sir, all of the above.
Everyone agree with this?
These are all of the above, but mostly we are using in half duplex.
Full duplex.
Okay. So it is all of the above. We can use it in any mode: simplex, full duplex, half duplex, and any mode we can use. Okay.
But sir,
Next,
mostly we are using in half duplex, right?
we are using in yes. It depends upon the use case actually.
Okay.
Okay. Next, the number of bits sent every second is known as bit rate, byte rate, baud rate. None of them.
Moderate.
Bit rate.
Others.
Bit rate, sir.
So don't get confused with this. The number of bits sent every second is known as bit rate, whereas the number of symbols sent every second is known as
Baud rate.
okay. So I hope this difference is clear. So in a symbol, you can send any number of bits. Okay, you can send one bit, then it will become bit rate. So baud rate and bit rate will be same. So if in a symbol, if you are sending more than one bit, then it is called as baud rate. Okay. So this is the difference between the bit rate and baud rate. So I hope this session is useful for you.